Hello. We're going to get started here. I get the wonderful job of introducing. So Tim has been teaching Python in many different contexts from university and school students since 2007. Among his many hats, Tim is CTO of Grok Learning, an online learning to code platform, and a lecturer at the National Computer Science School. So please welcome Tim Doughton speaking about stupid computers improving error messages for beginner programmers.
Hello, can you hear me? Yes, cool. Okay, so a little bit of pre-warning about this talk. So back when the talk proposals were put together, I'm like, sure, I'm going to have time to do a large-scale experiment before PyCon in the busiest work time of year. That sounds fantastic. And then when I get to August, I'm like, yeah, great. So I'm giving the same talk as what I proposed, just without a lot of the data that I intended to actually get at the time. I'm using data that we already had, but this talk would have been a lot better with some additional data, but we'll see how we go. So, who am I? I am one of the co-founders and I work at Grok Learning, which you may have heard of. It's a learning to code platform, primarily for school students. I'm also a lecturer at the National Computer Science School, and I've taught programming at the University of Sydney for many years. Primarily teaching since 2007 and primarily in Python. So a little bit of background about Grok, because it is relevant to the experiment that I'm going to describe later on. Grok is an Australian company. We're a scalable platform for learning to teach programming, delivering both our own courses and third-party courses to students and teachers around the world. And like a lot of other learning to code, well, there are a lot of other learning to code platforms out there, but one of our differentiating features is we strive to give meaningful feedback when people get things wrong. And that's kind of how we scale properly. We host and provide courses for primary school and high school students primarily. So there's around 3,500 schools in Australia that use Grok. We have many different classroom features to help teachers actually deliver these courses. But we also act as a platform as a service for universities to deliver their own courses for their own students. So we have around 25 university subjects from Sydney and Melbourne universities running on the platform currently. And so we have people all the way from kindergarten up to third-year university using this platform to learn to code. And there's a lot of different criteria you need to factor in to try and deliver content in an easy, understandable way to that diverse range of ages. Okay, that background aside. The other bit of background that's relevant to this talk, exceptions. What are they and why are they important? Exceptions are a way that are used to alter the normal control flow of a program. And in Python, there's kind of two main classes. There's going to be either compile time exceptions, which are going to be syntax errors, or there's going to be things that happen at runtime, which are normally going to be main errors, value errors, type errors, these kinds of things. Things that can't really be identified until something problematic happens when the code is actually executing. If these exceptions are unhandled by default, if the exceptions are unhandled, which is what happens by default, you'll get a stack trace shown as the application developer. So for example, this piece of code, which is some arbitrary thing I threw together just before, you're going to get this stack trace shown over here, which has multiple lines of output. It shows the call stack, so what happened to get to the point where the program failed, ends up with the exception name and a message about the exception. And this whole thing in red is highly incomprehensible. There's a lot of lines, a lot of red, a lot of symbols, a lot of punctuation, and not a whole lot of meaningful descriptive sentences in here. And this is for a case which is a runtime error. In the case of a syntax error, which is something like this, where we have name equals input, what is your name? We print out hello name, but we forgot the closing parenthesis on the first line. Our traceback says we have a syntax error at the word print, which is meaningless for multiple reasons. One, it's not print that's a syntax error. Two, the reason that we're given is invalid syntax. It doesn't tell us what we did wrong, or doesn't attempt to tell us what we did wrong. And this is only a 2-line program, and we've already got 2 things wrong with this exception message in terms of actually trying to deliver what is potentially wrong to the person who made this mistake. Okay, so why are difficult to interpret exception messages problematic, other than the very obvious reasons why they are problematic? This is again a bit of background. So, in Australia, there is this new thing called the Digital Technologies Curriculum. This is a brief timeline of what happened. Back in 2010, there was a shaping paper released. The first draft of this new curriculum was released in 2012. Curriculum was fully endorsed in 2015, and in New South Wales, the first kindergarten class will start with this new curriculum in 2019. That cohort will finish in 2031. This curriculum mandates programming from year 3-ish to year 10-ish for all students in Australia. And so there is going to be this large new cohort of students, of very young students in particular, learning to program, and a lot of what they'll be doing is Python. So this new curriculum has these kind of concepts in it. These are the concepts that are defined by the Australian Curriculum Assessment and Reporting Authority. But these are very high-level concepts and not necessarily easy to unpack by teachers. This curriculum is being rolled out through kindergarten through year 10. How many primary school teachers do you think have any real indication as to what algorithms might be able to teach algorithms without any teacher training? So I've stolen these slides from someone else, and these are great slides, these particular ones here. So this is Australia, in case you're not aware. We have a national curriculum called the Digital Technologies Curriculum. Ideally, this would be where this curriculum is taught. This is where the curriculum is currently being taught in some degree. This is the places that have the curriculum taught as it is written. This is these 3 other different variants of this curriculum that exist in Australia currently, other than the default one. And New South Wales is coming along in 2019, again with a slightly different flavour of the same thing. So while we do have this national curriculum, it is a national curriculum in the sense that it covers a lot of the similar ideas, but it's definitely varied across from state to state. So again, to get back to the original question, why are these difficult to interpret error messages problematic? Very soon, all primary school and high school students in Australia will be learning programming for the first time as a compulsory subject, often in the context of a teacher who doesn't have a background in programming or IT. Because this subject is compulsory, the teachers that are available at the school are going to deliver the subject, regardless of any background. This is true all over the world where there is compulsory programming, not just in Australia, but in the specific context of this talk, we're going to be focusing on the DT curriculum in Australia. And so everyone who learns to program makes mistakes. We all do. Even as developers ourselves, we make mistakes on a daily basis. The people who are learning to program, though, these mistakes can be highly frustrating, especially if you can't work out what is wrong. How many people have written code, especially things like C++? Everyone's written C++ templates, and you get 120 pages of output of template errors. You're like, where is the syntax error in this? It can be a highly frustrating experience, even as a seasoned developer. For a newbie programmer, in a 2-line solution where you have a syntax error and the syntax error is telling you it's on the wrong frickin' line, how frustrating can that get? So given that they're about to have all students in Australia have their first experience of programming, we want this first experience to be positive, as unfrustrating as possible, and to help teachers deliver this content. So it's important to make the delivery of this curriculum available to everyone equally across Australia, regardless of where they are. So someone in remote WA should get the same experience as in inner city school in Melbourne. And to do that, being able to self-recover when you make a mistake is important. Regardless of the surrounding context you're being educated in, if the system can help you self-correct when either you get a syntax error, a runtime error, or you produce the incorrect output, we can help people have an equal, everyone across Australia can learn in the same way. Sorry, that was phrased terribly, but... Okay, so when this curriculum was released, the Federal Department of Education tendered out a $10 million project for the development of some resources for this curriculum. This was won by the Australian Computing Academy, which in this talk is referred to as the ACA, who are part of the University of Sydney. There are both offline versions of these resources and online versions. They are all available under the Creative Commons license. And the online versions are available for free for students at Australian schools in grades 3 through 8. Why is any of this relevant to this talk? These free resources for all students in grades 3 through 8 are hosted on the Grok Learning platform. And so in Australia, there's currently around 3.8 million students and around 276,000 teachers. Theoretically, a large chunk of those students and teachers could be using these resources at any point in time in the immediate future. Given they're hosted on our platform, this is going to be their first experience in decoding. We want to give them the best experience possible and not scare them away. Because it would be highly unfortunate if we gave them their initial taste was a frustrating experience. So, how do people actually use the platform? I'm going to do a quick demo, because live demos are always a good idea in talks. Okay, they did work. So we have what we call the learning interface on Grok. We have a set of slides and notes, sorry, a set of notes and problems interleaved. So here down the side we have notes indicated with circles and diamonds indicated as problems. So it's notes which have text and interactive examples. So we can run this example. Is my internet connection going to work? Yes, it does. Brilliant. Hello world, and these examples are changeable, so I can change this to say hello PyCon. If I can spell PyCon, I can run it. And so we have notes, 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 notes. Problem. A problem requires reading a description of what you need to do on the side and developing a solution to actually answer that problem. So I'm going to say print hello world. I'm going to run it. To me, that looks close enough. I'm going to mark it and see whether it's correct. And it says no, it didn't print the correct words. I'm going to fix it up so it actually prints out the correct words and prints hello world. Mark it. No, we're missing the wrong punctuation. Fine. I'm going to fix it up. Hello, capital world with a W. Cool. And we got everything right. Yay. We can program. So let's jump ahead slightly to a different problem. So here we have a problem called Simon Says, which is your program should ask Simon Says, and then it should print out what Simon said. So this requires reading user input, storing that result in a variable, and then printing out that variable again. So we could have something like response equals input, Simon says, print response, response. And so we run it. Simon says, and we test it out. Simon says jump. And we test it out again. We say Simon says roll. That's not roll, but that's close enough. Off by 1 on the keyboard. Mark. And we didn't get the punctuation, the capitalization correct, sorry. So we correct that. Simon says jump. And we got it correct. Cool. And just because it's relevant in a second, the next problem in this course is read in input from the user, print out that input but with a string concatenated before it. So it is read in a noun and print out the amazing noun. Okay. So courses interleaved problems and notes. Notes are content, often with interactive examples. Problems require developing a solution to solve the task at hand. They have both examples in the questions of inputs and outputs, and they have test cases to test whether or not your program does the correct thing in the general case with hidden inputs. So solving a problem requires reading the description, writing code, then running it, checking whether the output's correct. If it is, you submit it to the marker to run it through the hidden test cases. If the hidden test cases say it's good, then you've solved it. If they don't, you go back to square one. Write some code, run it again, does it still work, mark it, etc., etc. So, moving a bit ahead. I've complained about exceptions this whole time, but not actually given you any evidence as to why we care about exceptions. So, on Grok, for all problems, we store the code that people write at all points in time. So we store, whenever people hit the run button, we store the code. Whenever people submit for marking, we store the code. Periodically, as they're developing their solution, we store the code. So we have a lot of code for a lot of these problems to work with as data points. Most intro to programming subjects that are hosted on the platform start with some variant of the following three questions. They start with some variant of Hello World. Then they go on with a problem that I'm going to call echo, which is read some input and then print out that input verbatim. And then the following question will be hello name, which is read some input and then print out some string followed by the name that was read in. And so let's have a look at these courses. Let's look at these three questions across a bunch of different courses. So for Hello World, we're going to look at it across 5 different courses. We have 2 versions of the same course run in 2 different years. We have the Australian Computing Academy's Chatbot course, we have the Grok Learning Intro to Python course, and we have a particular university's, a subject at a university that does Intro to Programming content. And so this is the number of times people hit the run button, how many times exceptions happen. And so there's quite a lot of exceptions that happen, even for Hello World. A simple program that takes no input, does no calculation, all it's doing is printing a single line of output. On average, 20% of the runs contain an exception of some description. And so if you look at these by exception class, 75 to 70, 71 to 79% of those are syntax errors in just Hello World. That many syntax errors. After that, name errors, which is surprising given name error normally involves a variable, an undefined variable. Indentation errors, and not that surprising, I guess, and type errors. And so by percentage, summed across all of those courses, as an accumulating percentage and the individual percentage, 50% of total exceptions to syntax errors, some. So these 5 exception messages, verbatim, for this particular problem cover 96% of all exceptions seen, which is not that surprising for this particular problem. Who's seen this one before? I didn't even know this syntax. Yeah, Nick probably implemented this particular exception message, so it's not entirely surprising. I only found this one very recently. I went and looked at how it was implemented, and there's a specific hack for both print and exec in the parser to identify that you're missing parentheses. So looking at the echo problem, so that is read some input, print out that input verbatim. Again, runs with exceptions, 40%-ish. Very, very high. And again, that same breakdown. So less syntax errors, many more name errors. Again, not overly surprising, but still very large percentage of syntax errors for this simple program, which is variable equals input string, print variable. And again, with actual exception messages here, syntax error, invalid syntax, the generic fallback syntax error message is almost 60% of all cases here. So no specific hinting to tell you what went wrong, just the generic invalid syntax. And then in hello name, again around 35 to 40% exceptions. Broken down by class is less syntax errors, more name errors, and many more type errors. Why might there be more type errors here this time? You want to have it in? Integers? There is no integers.
What is your name? One. Like the number one.
Yep, except we're calling input, not raw, not exact input. So you're not going to be able to get an integer as input. It's going to be the concat operator. Yeah, string concatenation. People accidentally trying to plus together things that aren't plusable. Yep. Again, these 5 exact error message strings cover 91% of all cases of people getting things wrong here. So how can we make exceptions easier to understand, given this? Here, I was going to do a live demo of this next little bit, but we'll see whether I get time. So here is an example from before of this very simple 2-line program where not only does the parser tell me the wrong line number, it points at the wrong thing that is wrong. It's not actually the print. Like technically, according to the grammar, yes, the print is the token that is wrong here because you can't have a string directly followed by an identifier. But what's actually gone wrong here is the missing parentheses. And so what can we do to make exceptions easier to understand? This is a very hard problem to solve from the kindergarten to third-year university case as a general problem. Different age groups are going to have different reading levels. There are multiple different ways we could solve this problem, and there are multiple different problems within this problem. There is both the message that's conveyed, there is the readability and comprehensibility of the rendered stack trace, and there is the line number / pointing at the wrong thing issue to do with syntax errors. Kind of 3 very disjoint problems here. And so 2 ideas, just to throw things out there, would be to wrap the code that gets run with some kind of per problem specific handling of what students commonly get wrong and try and account for that, both by looking at the input and output and by looking at their code. Another approach would be to change some of the default error messages that come from both the standard library or the parser, and or add some better guessing within the parser as to what may have gone wrong. Or option 3. So again, what data do we have? We're going to look at those same 3 courses, the same 3 problems across a bunch of different courses. And to do that, we're going to analyze this historical data, add at runtime specific hints for the most common ways people fail these problems. And we're always going to show you the raw output from Python because we don't want to hide. The Grok mentality of this stuff is to show you the real world stuff. Don't hide anything, but give you a better annotated version of what may have gone wrong. So by adding proactive hints, we hope to reduce the number of runs and marks it takes someone to solve the problem. We hope to reduce the time it takes to solve the problem as well. Hopefully increase the number of people who successfully solve the problem. And so we're going to call this sequence of run, mark until we solve a problem a path. And so in terms of those analyses, we want to reduce the path length and reduce the duration between the start and end of a path. And we're going to do this across the 2017 and 2018 versions of the same course content. The 2018 version has this hinting enabled, the 2017 version does not. I'm going to give you screenshot demos because I'm running low on time as opposed to doing a live demo. But if we have code like this in Hello World where we just put in the output verbatim, not in quotes and not with a print statement, you're going to get a syntax error on exclamation mark because that's not a valid identifier or token in the grammar. But we go and annotate both the code and the output with hopefully helpful messages as to what went wrong in both of these cases. So explaining what a syntax error message means and annotating what you've done wrong up here. So the hint says you probably meant to put this in quotes. So we go and put it in quotes, we run it again and says you produce no output. Did you perhaps mean to print out that string? So we can then go and print out that string, and then we solve the problem. And so we jump to Simon Says, and we have a very similar thing. We can annotate. I'm going to walk you through slightly. We jump to adding it in strings, printing them both out, changing the first one to be a call to input. We then tell them that you put the input from the question as part of the prompt string, which is not correct, yada, 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 and so on and so on. To jump to the analysis of this, did this actually make a difference? So on Hello World, in blue, we have the percentage of students who solved it within path length n in 2018. So there's with hinting, and 2017 is without hinting. So the answer here is yes, kind of. We've reduced the path length that it takes people to solve Hello World by quite a bit. And in terms of duration of time, this is in terms of the x-axis is minutes, how long it takes someone to solve the problem from when they first started to when they actually solved it. We also increase the number of students who solve it quicker. In terms of echo, yep, we reduce the path length again and slightly sped people up. And of course, these are going to have a cascading effect. If you can get people more comfortable earlier on, the later on problems are going to be more comfortable and make less of the same mistakes. Hello name does not necessarily have an increased path length. In fact, at the very beginning, it has a slightly, decreased path length. At the beginning, it has slightly increased path length for reasons that need further analysis. However, the duration was still quicker. And so the vague summary of this was adding this kind of hinting seems to have made a difference, which is good. These were 95% coverage of all exception messages that we had. As a quick summary, what is wrong with these? Pick any one of these. What is something that's wrong with any of these messages for a beginner programmer? The first one, invalid syntax. What does that mean? That tells me absolutely nothing. Syntax error, EOL while scanning string literal. If I'm in year 3, what does EOL mean? What does scanning mean? What is a string and what the heck is a literal? Name is not defined. It's arguably better. Missing parenthesis and call to print. Hey, that's at least descriptive. Good work, Nick. Indentation error, unexpected indent. What is indentation? We've not explained it. At this point, we've not dealt with any kind of nesting structure. We've not covered indentation. This is not necessarily criticism of the grammar of the parser here, but this message is not at all helpful in this context. And syntax error, this is very similar to the one up here. Unexpected EOF while parsing. Unexpected is a giant word. EOF is an acronym. Parsing, what the heck is parsing? And these are the ways that people hit these, just to see some concrete examples. So invalid syntax, forgetting to actually put quotes around the string. And again, this same invalid syntax with the wrong line number by missing a paren. EOL while scanning string literal. You start a string, hit the end of line, and you don't find the closing string. Name error. You can plus together variables with strings, so why can't you plus together all of the bits of the output message? Syntax error, missing parens and call to print. That one's kind of obvious. Indentation error. Who can spot why this has got an indentation error? Can a year 3 student spot why this has an indentation error? No. Again, this output here tells me absolutely nothing about what I've done wrong. This looks identical to the previous one. This one's great. A 2-line program, I have an exception on line 3. That is blank. And so there is lots of room for improvement here. Learning is hard. Syntax is hard. What can we do about it? Better automated support for when people get things wrong, such as this hard-coded hinting stuff we've done. We can make error messages less full of jargon, less terse, add some more descriptions, and add better suggestions or better corrections for common syntax error mistakes. We could when teaching programming to this younger cohort, instead of going straight into text-based programming, we can lead them in with block-based programming where you can't make syntax errors. So you can teach the programming concepts first and then gradually get to syntax. Or we could encourage the use of IDEs that can't really allow you to do syntax errors. It's a bit halfway between block-based and text-based, or maybe something else. And I'm out of time, so that is it, sorry. Thank you.
All right. If you have any questions, we would invite you to move out into the hallway to ask questions as we are going to get set up for